All right, one last thing we've got to look over before we can jump back into doing financial plans for development projects from a developer's perspective, and that's to review a little bit what you've learned with Professor Odette on compounding periods and to expand on that a little bit. Okay, so far everything that we have done in this module and in the previous module is to use annual compounding. So R% meant R% interest per year. And t was always a real number. It didn't have to be an integer, but we always measured time in years. Now we need to be, and in the real world, we need to be much more flexible. We need to consider quarterly, monthly, daily compounding, any of those, bi-weekly compounding, semi-annual compounding. And the great news, as you learned from Professor Odette, is that everything we have done regarding time value and everything you did with Professor Odette can be generalized to longer or shorter compounding periods by simply changing time units consistently. And you'll see what I mean by that. So we want to make this change consistently, and that means R and T. Okay, so for example, if we have quarterly compounding periods, we're going to say R% interest compounded quarterly. That means R% is paid every quarter. And we're also going to say, if we're in a quarterly compounding world, t equals 0 will still mean now, as usual, but t equal 1 will mean one compounding period from now, something like 1 quarter from now, okay, if we're in a quarterly compounding world. So let's do an example. Let's consider a 3-quarter mortgage. Okay, so it's going to be a really short payback mortgage that happens in 3 quarters. So out there in the big bad world, Big Shark Lenders offers Mr. Small Net Worth this mortgage loan. Okay, they'll loan him $30,000 to help him buy a $50,000 shack today. So that means Mr. Small Net Worth is going to have to, of course, pay $20,000 of his own money. He would be what we would call the equity or the property manager in this property, even though it's his own property. And here's the deal. Mr. Small Net Worth would have to agree to pay Big Shark back. He's going to get this $30,000. He has to pay back in 3 equal quarterly payments with 10% interest compounded quarterly. How much? We want to know for Mr. Small Net Worth, how much is each quarterly payment? So let's go ahead and check this out. What's the situation here? We have this $30,000 he's going to get, 10% compounded quarterly. So this PV total is going to equal 30K. That's going to be equal to his payment 1 discounted by 1 quarter. Okay, and this is 2 quarters here, and this is 3 Qs here. So the first payment going to be payment 1 discounted back in 1 time period with R measured in quarterly compounding. Okay, same thing for the second payment. It's going to be discounted back by what? 2 quarters now. So that's why we have 2 in the exponent, and we got to remember we have quarterly compounding in R. Similarly for payment 3. So we want to note that we said by definition all these payments are equal. Okay, so we can simplify a little bit. We can pull payment out, okay, and this is still equal to 30K, all right? So I've just done a little bit of algebra on this line to simplify, and now I've done some more algebra down here to isolate that uniform payment he's going to have to make, and if you do the algebra on that, you find he has to pay $12,060 per quarter. All we had to do this, exactly the same as everything we've done annually, except we've consistently changed all our units to quarters. So R is interest per quarter, compounded quarterly, and T is measured in quarters. And that's it. It's really that simple. All right, so in general, you're going to find in the real big bad world of finance generally, real estate finance in particular, projects will be done in monthly time periods, quarterly time periods, semi-annual time periods, sometimes biannual time periods, and to understand one project compared to another, we want to put everything in annual compounding periods. It just makes it easier for us to understand, and it's necessary to compare different projects. So the way we do that is with what's called the equivalent annual interest rate. What is the equivalent annual interest rate? Defined to be the amount of interest generated in a year by a pile of money, irrespective of compounding period. Okay, so here's how it goes. The EAIR, that's the amount of interest generated in a year, okay, is going to be 1 plus R, where this is going to be monthly, quarterly, or etc. Okay, so that's called our native R, 1 plus our native R, monthly compounding, quarterly compounding, semi-annual compounding, raised to the number of compounding periods per year minus 1. Why do we do this? Again, we use EAR to make these apples-to-apples comparisons of interest rate projects with different compounding periods. Okay, so let's go on a little farther and see how exactly this works. Let's do two examples. First one is, let's say, what's the equivalent annual interest rate of Big Shark's offer to Mr. Small Net Worth, that 3/4 mortgage? Remember, it was 10% compounded quarterly. So if we're thinking about it, as most people do in annual terms, let's see what the equivalent annual interest rate is. So all we do is apply the formula. Okay, so we have for Mr. Small Net Worth, the offer on the table is 10% compounded quarterly, okay, and plugging in the formula, 4 compounding periods, 4 quarters per year, so we have 1 plus 10% raised to the 4 minus 1 equals a whopping 46%. Actually, this in the United States is considered usurious and is an illegally high rate, okay. So by comparison, a more normal and legal in the United States lender might have offered Mr. Small Net Worth something like this, 10% compounded annually. What's the equivalent annual interest rate of that? Well, it's of course 1 plus 10% raised to the 1 yearly compounding period in a year minus 1 equals 10%. Okay, so this is a good way to understand what interest rates are in a time frame that we're all used to. And it's very good and very necessary to compare projects under some circumstances. Here's another example where we see how it's necessary to compare projects. So let's say you're considering throwing some money in a money market and you have two banks. Bank 1 says we'll give you 5% compounded annually. Bank 2 says we'll give you 0.375% but compounded monthly. Which one is better? Well, we have to convert everything to annual too, so we can do apples to apples. So for Bank 1, the equivalent annual interest rate, it's already in annual compounding terms, that's 5%. For Bank 2, we just apply the formula, 1 plus R raised to the number of compounding periods per year, 12, in the case of monthly compounding, minus 1 equals 4.6%. So Bank 1 is clearly offering a better deal, but we have no way of knowing that until we put everything in annual terms.